Hello everyone, welcome back to the new session. This is Mr. Nisar, the Maths Guru. In this session, we will be solving exercise 21B of Trigonometrical Identities. Let's go on the screen. So we have the first question on the screen. MCQ, it's given that 1 plus cot square A plus 1 plus tan square A is equal to what? Okay, children, very interesting question. If it is 1 plus cot, come on, say me what are the three trigonometrical identities? Based on that, this question is there. So can I say that 1 plus cot is what? 1 plus cot is cosec. So 1 plus cot is cosec. I'll write here cosec square A plus I have 1 plus tan, and 1 plus tan is nothing but it is sec square A. So cosec square A plus sec square A. So here we don't have this option. Okay, so what I'll do, see, lot of time I said you, whenever you have such questions of trigonometry, try to convert it in terms of sine on cos. So cosec is reciprocal of what? Cosec is reciprocal of sine. So can I say that 1 by sine square A plus sec is what? Reciprocal of cos. So 1 by cos square A. Now what we'll do, children? Cross multiplication, 1 into cos square A. It will be cos square A plus sine square A into 1, it will be sine square A upon sine square into cos square A. So what we are doing here, cross multiplying it. Whenever the denominators are not same, we do cross multiplication. Now you say it is cos square A plus sine square A, or sine square A plus cos square A. What it becomes? It becomes 1. I hope you are able to see the answer on the screen. See, in trigonometry, you should be able to see the further step. So I got 1 by sine square A into cos square A. So can I say that 1 by sine, reciprocal of sine is what? It is cosec, and reciprocal of cos is what? 1 by cos square A. It is sec square A. So cosec square A into sec square A. Which option it is? Option number 4. I hope it is quite clear to you. Let's go ahead for the next question. So the next question we have, children, it's given that if A is equal to tan theta and B is equal to sec theta, find the relation between A and B. Very simple question. Now first of all, you say me, before solving this question, what is the trigonometrical identity which relate tan and sec? So I say that it is 1 plus tan square theta. 1 plus tan square theta is sec square theta. This is the trigonometrical identity we have. So by observing the option, if I transfer this plus tan to this side, what will happen? It will become sec square theta plus tan will go to this side, it becomes minus tan square theta is equal to 1. Okay, now let's see what's given in the option. Now here you see tan theta is given as A, so it is tan square theta, so I'll say that it is A square. Sec square theta is B, sec square theta will be B square, so it is B square minus A square is equal to 1. Which is that option, children? B square minus A square is equal to 1, option number C. I hope it is quite clear. Let's go ahead for the next question. Yeah, so the next question we have on the screen is 1 by cot theta plus tan theta. We have to find out in this. So children, the question is quite simple. The trick is given in the question itself. It's given 1 plus tan theta. So here you say me, in the options, if you see, children, it's given in terms of sine and cos. So what should be our first step? Try to convert it into sine and cos. So can I say that cot theta is nothing but it is cos by sine. Cot is cos by sine. And what is tan then? Tan is sine by cos. Yes. Now what we'll do in the next step? Cross multiply. Okay, as the denominators are not same, so cos into cos, it's going to become cos square theta. Sine into sine, it's going to become sine square theta. And in the denominator we have sine theta into cos theta. Now say me, 1 upon cos square theta plus sine square theta, it's going to become 1 upon sine theta into cos theta. Is it? Now when a fraction is there in the denominator, what it happens? Already it is taught to you, it becomes a reciprocal. So sine theta into cos theta. So this should be our answer, option number 2, sine theta into cos theta. So what was this question all about? It was converting the given trigonometric identity in the form of sine and cos. Let's go ahead and solve next question. Yeah. So the next question is on the screen, D1. It is sec theta minus cos theta whole square minus sec theta plus cos theta whole square. Okay. And this is equal to what we have to find. So children, say me here, can I say that this is a minus b and a minus b whole square, and you know that the formula for a minus b whole square, what it is? If I say this as a minus b whole square, and this is nothing but what it is? A plus b whole square. So apply the formula here. A minus b whole square become a square minus 2ab. 2 into a is sec theta, b is cos theta, plus b, that is cos square theta, minus, then we have in the second bracket, see, whenever you have minus sign before the bracket, try to write in the bracket, so that when you open it, the signs will get changed. So a plus b whole square become a square plus 2 into ab, 2 into sec theta into cos theta, plus b is what here? Cos square theta. Yeah. Then if I solve it, I am going to get sec square theta minus 2 into, now you see children, here it is sec and cos. So can I say that this cos, this sec is reciprocal of cos, so I can write it as 1 by cos theta, and here I already have cos theta. What I have done here, this sec I have written in as a reciprocal of it. Why? Because this both will get cancelled, and here I have cos square theta. Now whenever the minus sign is there before the bracket, all the signs inside the bracket, it will get changed. So it becomes minus sec square theta, plus will become minus 2. Again here sec theta into cos theta is there. So what I'll do children, instead of this cos theta, I'll write it as sec theta, or you can write sec as 1 by cos. This is one and the same thing. Okay, here I have written instead of sec as 1 by cos, here I am writing instead of cos 1 by sec. These are one and the same thing, just we are doing the reciprocals, we are the writing reciprocals of each other, and this plus will become minus. Okay, then if I cancel this both will get cancelled. Okay, and here plus cos square theta minus cos square theta, this is also going to get cancelled. So what is remaining now? Here also sec square theta minus sec square theta, this is also going to get cancelled. Here cos is going to get cancelled. So here we are left with minus 2 into 1, that is minus 2, and here we are left with this minus 2. So minus 2 it's going to become minus 4. So that is option number 4. I hope it is quite clear. Just we applied the formula for a minus b whole square and a plus b whole square. Okay, I hope it is quite clear. See, when we open the bracket here, it was plus, so it becomes minus. So this plus cos square theta and minus cos square theta, this is going to get cancelled. Just I'll underline it. This and this will get cancelled. Even here, what this and this sec square theta will also get cancelled. I hope it is quite simple. Let's go ahead for the next question. The next question we have children, cot a minus cot b whole square plus 1 plus cot a into cot b whole square is equal to what? Again we can see that this is a minus b whole square and this is a plus b whole square. So I'll apply the formula for a minus b whole square. It becomes a square minus 2 into ab. A is cot a, b is cot b, plus b square. Okay, then we have plus. See, when there is plus, there is no worry about the sign. So a square, this is your a here and this is your b. So a square plus 2 into 1 into cot a into cot b plus b square. So can I say that the square of b is cot square a into cot square b? Fine. Now see, minus 2 cot a cot b plus 2 cot a cot b, this both will get cancelled. What is remaining now? We are left with cot square a plus cot square b plus 1 plus cot square a into cot square b. Then what we can do here children? See, here I can see that this is 1 plus cot square a. So 1 plus cot square a, it becomes what? 1 plus cot cosec square a. And in the remaining terms, okay, now in the remaining is what? Cot square b plus cot square a into cot square b. Here I can find that this cot square b is common in both the terms. So I'll take that cot square b outside the bracket. So I have taken that cot square b outside the bracket. What will remain here then? See, I am talking about this. I'll just change the color. Yes, you see this one. I'm just talking about this too. I can take common from this now. What I have taken common? Cot square b I have taken common. So it will be 1 here plus cot square b is outside. So here it will be 1 plus cot square a. Okay. So from this two I have taken cot square b common. Now I can see that 1 plus cot square a. 1 plus cot square a is what? 1 plus cot square a is what? Yes, 1 plus cot is cosec. 1 plus cot is again cosec. So I'll say that this is cosec square a. Then in both the terms, what is common? Again I can see here in both the terms cosec is common. So I'll take out cosec outside the bracket. It will be cosec square a outside the bracket. What will remain here? 1 will remain here plus. From here cosec is outside. So what will remain in the bracket? Cot square b. So cosec square a in bracket 1 plus cot square b. Do we have this option? Still not. So again here you see 1 plus cot. 1 plus cot becomes what? 1 plus cot is going to become, yes, it's going to become cosec square b, and I hope this option I am able to see. That's option number 4. I hope it is quite clear to you children. So let's go ahead to solve the next question from the exercise. The next question is about prove that left hand side is equal to right hand side. We have solved lot of such type of question in the previous exercise. Again we have same type of question. So children, what I'll do here, in the left hand side I'll take left hand side and we'll prove it as 1 minus sine a. So what is the first step? What we will do here? Say me. Yeah, lot of time I have said you, whenever you see such type of things, try to convert it into sine and cos. So can I say that sec a? Sec is reciprocal of cos. So I can write as sec a as 1 by cos a minus tan a can be written as, tan is nothing but sine by cos. So I have written that sine by cos whole square. Then we have 1 plus sine a. Children, now here the denominators are same. So can I say that when the denominators are same, what we do? We write the denominator once. So it will be cos a 1 minus sine a, and it is whole square. So I'll separate that square. I'll give that square 1 to this one, or I'll just increase one more step. Yeah, I'll increase that step. So here it will be 1 minus sine a. The denominators are same, so I am writing the denominator once, and 1 plus sine a. Then what will happen? Just separate it. 1 minus sine a whole square upon, I am just separating the power here. See, this I was saying, which I was writing direct there. It will be 1 plus sine a. What can be the next step here, children? If I just elongate it, yeah. What can be the next step here? Yeah. See, what we want everything in terms of sine. So I'll convert this denominator cos square a in terms of sine, and in the numerator I can see it is 1 minus sine a whole square. So can I say that whole square means this is 2 times bracket. So 1 minus sine a. This we have to write how many times? 2 times. So 1 minus sine a into 1 minus sine a, and in the numerator we have 1 plus sine a. Okay, and in the denominator what I am going to do is I am going to convert that cos square a as cos as 1 minus sine square a, the first trigonometric identity. Then here I got again, see, this is what I'll say that this is nothing but a square minus b square, and a square minus b square, you are aware about it, what it is. See, I'll just draw a line over here. Yeah, then we'll move ahead. Yeah, so here it will be 1 minus sine, I'll write as it is 1 minus sine a into 1 minus sine a, and it is 1 plus sine a. And in the denominator we have a square minus b square, which is going to become a minus b and a plus b. And I think that this and these both are same in the numerator and denominator. This both will get cancelled and the answer will be 1 minus sine A, which is equal to your RHS. I hope it is quite clear. Let's go ahead for the next question. Yeah, the next question we have, third one, cos cube A plus sine cube A upon cos A plus sine A plus cos cube A minus sine cube A upon cos A minus sine A. This we have to prove this as 2. So children, this is very important question and this type of question was asked in the exam as well. Now see, in this question, if you don't know the formula for A cube plus B cube, then you will be not able to solve this question. So you should know the formula for A cube plus B cube here. And what is the formula? A plus B, A square minus AB plus B square, and A minus B, sorry, A cube minus B cube, the formula is A minus B, in the second bracket all the terms are positive, A square plus AB plus B square. See, you should know this formula, and if you don't know this formula, you will stuck in this question and you may lose the mark. This type of question, once it was asked in the exam, and if the child don't know the formula for A cube plus B cube, then it will be difficult for him to solve this one. So what I'll do here, I'll apply the formula A cube plus B cube. It will be, see, let us consider this as A and this as B. So it will be A plus B, that will be cos A plus sin A. This is A plus B. We have A square, A is cos, so cos square A minus AB, that will be cos A into sin A, plus B square, that is sin square A. Then we have in the denominator cos A plus sin A, plus A cube minus B cube. So A cube minus B cube, it will be A minus B, that will be cos A minus sin A. In the second bracket we have A square, that is cos square A, plus AB, AB will be cos A into sin A, plus B square, B is sin, so that is sin square A, upon, it will be cos A minus sin A. So what we have done the expansion of A plus B, A cube plus B cube, and A cube minus B cube. Now children, you see this cos A plus sin A, this is multiplication with the brackets, and here also we have in the denominator cos A plus sin A. So these both can be get cancelled, and here also you see cos A minus sin A, cos A minus sin A, this both will get cancelled, as cos A minus sin A in the numerator it is in multiplication. When the terms are in multiplication, you can cancel it. So in the next step, what I'll do, I'll write whatever is left. So cos square A minus cos A sin A plus sin square A plus what is left there, cos square A plus cos A sin A plus sin square A. This much is left. So children, what I can do here, I can see here minus cos A sin A and this is plus cos A sin A. This both will get cancelled, minus plus. Now if you see what is remaining, cos square A plus sin square A, here also cos square A plus sin square A, and you are aware about that cos square A plus sin square A is going to become what? 1. So I'll just combine this together. So I'll write first, okay, no problem, we'll write cos square A plus sin square A. Now this type of question they may come for 4 marks. And what is remaining in the second part? Again here, cos square A plus sin square A. So can I say that cos square A plus sin square A is 1? And here also cos square A plus sin square is what? 1. And 1 plus 1 we have 2, which is equal to RHS. I hope it is quite clear to you. Let's go ahead for the next question. The next question we have, children, tan A 1 minus cot A plus cot A upon 1 minus tan A. This we have to prove as sec A into cosec A plus 1. Now children, this question can be solved in 2 ways. Okay, one is some shorter way and one is some lengthy way. So one way I'll solve here right now, and the second method I'll give you in the notes. Okay, so both methods will be with you, and whichever is convenient for you, you can use that one. So I'll explain you with the easy method here. So what we need to do is here, see, we need to convert it into sec and cosec. Okay, so first of all, what I'll do here, I'll convert this cot in terms of tan only. Why? Because it will be easy for me to convert it into sec. Okay, because see, we have the relation of sec with tan, so I'll convert this cot in terms of sec. So what I'll do here, children, I'll take left hand side and I'll write this tan a as it is, the numerator. In the denominator, 1 minus cot can be written as cot is 1 by tan. Cot is reciprocal of tan, so 1 by tan a I have written in this way. In the same way, I'll write here for the second one, cot is 1 by tan, and in the denominator I have 1 minus tan a. Okay, then what I'll do, cross multiply. So can it look like this? In the numerator I have tan a, and in the denominator will be just cross multiply here, tan a ones are tan a, minus 1 into 1 upon tan a, plus here in the numerator I have 1 plus tan a, and this both goes in multiplication. Like I have already taught you this property, when you have a fraction and there is a single number, this both goes in multiplication. A by BC it becomes, okay, this you see in the conceptual video, the first video. So this becomes 1 minus tan a. Then how to proceed ahead? A fraction, here you have a numerator and in the division you have fraction. When a fraction is division, what it happens, it becomes reciprocal. So it will be in this way, tan a into, just it reciprocal, it will be tan a upon tan a minus 1, and here we have 1 by tan a in bracket 1 minus tan a. Okay, now what will happen, children? Tan a into tan a, it becomes tan square a. I'll just draw a line here. Yeah, so here I'll be getting tan a into tan a, it will be tan square a upon, in the denominator I have tan a minus 1, plus here I have, children, here I want you all to concentrate, very important step here we have. If I see this, no, here I have tan a minus 1, is it, and here I have 1 minus tan a. What I need, I want this tan a minus 1, here also I want tan a minus 1. So why I want this? To make the denominator same. So you will say that, sir, here in the denominator we have tan a also. So to bring here tan a in the denominator, what we'll do, we'll multiply the numerator and denominator by tan. Why we are doing this? To make the denominator same. It means we are trying to find the LCM here. So I want same here, tan a into tan a minus 1. So see, for this what I will be doing, first of all what I'll do, I'll write that steps and then I'll explain you. See, first of all I'll write it as it is, tan a 1 minus tan a. Okay, here nothing I have done, I have just multiplied tan a into tan a. Now I want to make the denominator same, it means I want to take LCM. So for that what I will be doing, children, see, I'll just change the color. Yeah, I'll show you with the white color here. I want in the denominator here tan a. So what I should do for this tan a, I should multiply the numerator and denominator by tan a. This into tan a and here also into tan a. When we multiply the denominator, we should multiply it with the numerator also. Okay, so what it becomes now? So if I see in the next step, it's going to become, tan square a into tan a, it become tan cube a. And in the denominator we have tan a minus 1, is it? And here you see now, as I said you, I want to change it as tan a minus 1. So to change it as a tan a minus 1, I will take out this minus sign outside. So it becomes minus 1 by tan a minus 1. Okay, I have taken the minus sign outside so that the signs inside the bracket get changed. Now here the denominators are same. So what we can do, when the denominators are same, write the denominator 1. So I'll have tan a minus 1, the same denominator I have written it once, and numerator, if addition is there, do addition, if subtraction is there, do subtraction. I have just combined the denominators. Okay, let's go ahead. Just give me a minute, I'll just change my position. Yeah, so here now what happened, children, it becomes a cube minus what is over here, b cube. When 1 is there, you can consider 1 square, 1 cube, whatever it is. So a cube minus b cube. We have seen the formula for a cube minus b cube in the previous question. I'll write it once again here. The formula will be a cube minus b cube. The formula we have for it, it is a minus b. Then the second bracket we have a square plus ab plus b square. In the minus, in the second bracket, all are positive. So I'll use that formula. I will be getting, first is a minus b, that will be tan a minus 1. This is a minus b. Then a square minus a square. A is what? Tan square a. A square plus ab. A into b is, a is 1, b is, sorry, a is tan a, b is 1. So tan a into 1 plus 1. And the denominator I have, that is tan a into tan a minus 1. So can I say here tan a minus 1 is in the numerator also and in the denominator also, this both will get cancelled. So we have now, I'll draw one more line here. Yeah. So what's remaining with us now? Children, see, now this 1 plus tan square a, this I am talking about, this tan square a plus 1. 1 plus tan square a, what it become? Yes, it's going to become sec square a plus tan a in the numerator, and in the denominator what is remaining? Tan a. Now from here you should be able to see the answer. See, tan a by tan a, it's going to become 1, and here what will remain? Sec square a by tan a. I'll write it over here. So I'll separate here the denominator, so it will be sec square a upon tan a plus tan a by tan a. Now see, one more method which I said you, that method is lengthy than this, it is the shorter one. So that method is converting that tan into sine and cos. You can use that method as well. Okay, that I'll send you in the notes, that you can see, or you can try by your own, you will get the answer for sure. So here sec square a we have. Can I write that sec square a as, sec is 1 by cos, so 1 by cos square a upon tan, I'll write it as sin a by cos a, and here we have tan a by tan a, it is 1. Now see, children, what will happen? It will become reciprocal. So this 1 cos and 1 cos will get cancelled. Is it? If I write here 1 by cos square a into cos a by sin a plus 1. So here cos will get cancelled, and what is remaining now? It is remaining here 1 by cos upon 1 by sin. So 1 by cos is going to become sec, and 1 by sin is going to become cosec. So the final answer we need to write here. Okay, I'll write it over here. What is remaining? 1 by cos. 1 by cos means sec a, and 1 by sin is remaining. 1 by sin means cosec plus 1. This is equal to RHS. I hope it is quite clear to you. It was a good question. Okay, let's go ahead for the next question. So the next question we have tan a plus 1 by cos a whole square plus tan a minus 1 by cos a whole square. We have to prove it as 2 in bracket 1 plus sin square a, 1 minus sin square a. Okay, so children, what we'll do, we'll take left hand side and we'll start with trying to convert it into sin and cos. So can I say that tan a can be written as sin a by cos a, sin by cos plus 1 by cos a, plus then again I have tan a, it will be sin a by cos a minus 1 by cos a. Okay, now here the denominators are same, so I'll write the denominator once. I'll be getting cos a sin a plus 1, and and here also denominators are same, they are the like fraction. When the denominators are same, we write the denominator once. If addition is there, do addition in the numerator. If subtraction is there, do subtraction in the numerator. Okay, then I'll separate the powers. It will be sin a plus 1 whole square upon cos square a. Here also I'll separate the power. It will be sin a minus 1 whole square upon cos square a. Okay, now the denominators are same. Write the denominator once. That will be cos square a, and if addition is there, do addition. If subtraction is there, do subtraction in the numerator. So here we have sin a plus 1 whole square plus sin a minus 1 whole square. So what I'll get, a plus b whole square plus a minus b whole square. How to do it? See here. Yeah. So a plus b whole square, it will be a square plus 2ab, 2 into sin a into 1, plus b square. Then we have a minus b whole square. So this is a square minus 2 into ab plus b square. I'll take it down. Minus 2ab plus b square, that is 1. And in the denominator we have cos square a. Children, now see in the denominator here we have in terms of sign. So I'll convert that cos into sin. It becomes 1 minus sin square a. Okay. Then what can be done? Plus 2 sin a minus 2 sin a. I am able to see this, both will get cancelled. And here 1 plus sin square a plus sin square a, it's going to become 2 sin square a. Yeah, I think so we got the answer. And 1 plus 1 is going to become 2. That this 2 will come common outside the bracket. Yes. So 2 in the numerator, in the both the terms 2 taken common outside. So we are left with in the denominator and in the numerator sin square a plus 1, and here we have 1 minus sin square a. Okay, I hope it is quite clear to you and it was an easy question. Let's go ahead for the next question. The next question we have, children, here 2 sin square a plus cos to the power 4a. Okay, very easy question it is. See what I said you, whenever I'll write first left hand side 2 sin square a plus cos to the power 4a. See, this I have repeated so many times in this series that whenever to the power 4 is there, what we should do, we should try to convert it into the power 2. So can I say that this cos to the power 4 can be written as cos square a whole square a? Is it? Then now I'll write here 2 sin square a plus cos can be written as 1 minus sin square a, and this will be whole square. Then can I say here 2 sin square a plus, now you can apply the formula, expand a minus b whole square, a square minus 2 into a into b plus b square. Okay, then yes, I can see here plus 2 sin square a and minus 2 sin square a, it's going to get cancelled and it's going to become 1 plus sin to the power 4a. Okay, very simple question, it came in the middle. Okay, previously we have solved some lengthy questions. Okay, let's go ahead for the next one. The question is sin a minus sin b upon cos a plus cos b plus cos a minus cos b upon sin a plus sin b. Children, this type of question we have already solved in the previous exercise. Just here we need to do cross multiplication. So if I cross multiply sin a minus sin b into sin a plus sin b, see here I'll cross multiply, I'll write here in the first bracket I'll have sin a minus sin b into sin a plus sin b plus in the second bracket I have cos a minus cos b into cos a plus cos b upon this both will be multiplied, so cos A plus cos B into sin A plus sin B. This all we have to prove as 0. What does it mean? You know children, if we want the answer as 0, then somewhere in the numerator 0 is going to come. Okay, let's see whether it will come or not. So here you see, this is A minus B into A plus B. Is it the same pairs with the opposite sign? A minus B into A plus B, it's become A square minus B square. So I'll write here sin square A square minus B square. And in the second bracket I have again A plus B into A minus B, it's going to become A square, that is cos square A minus cos square B. The denominator will be as it is. It will be cos A plus cos B sin A plus sin B. So if I open the bracket in the numerator, it will be sin square A minus sin square B plus cos square A minus cos square B upon, see, as I said you, something 0 should come in the numerator, and I am able to see that 0. I hope you might be able to also see that, because sin square A plus cos square A, it's going to become 1, and cos, I'll just let you know there. Yeah, see here, the sin square A plus cos square A, is it going to become 1? I'll write it over here only, yes, 1. And if I take minus sign common here, again in the bracket I'll have sin square B plus cos square B. Okay, and that is going to become what? Again 1 minus sin square plus cos square, it is going to become 1, and 1 minus 1 is 0. Okay, so 0 by anything, answer will be 0. Just I need to write this one. Yeah, very lengthy step, no problem. So it is 1 minus 1, that is equal to 0. Okay, and 0 by anything, the answer will be 0 only. I'll write it all together. It will be 1 minus 1, and the denominator you can copy as it is. So it will be 0 by anything, and 0 by anything, it will be 0. I hope the concept is quite clear to you. Let's go ahead for the next question. Children, the next question is cosec A minus sin A into sec A minus cos A. You have to convert it into 1 by tan A plus cot A. This type of question we have already solved in the previous exercise. You may say me what to do here. Yes, try to convert it into sin and cos. So cosec, I can write it as 1 by sin A minus sin A, and sec can be written as 1 by cos A minus cos A. So just cross multiply, 1 into 1 it will be 1 minus sin into sin, it will be sin square A upon sin A into, again here 1 into 1 it will be 1 minus cos into cos, it will be cos square A upon cos A. Okay, now 1 minus sin becomes what? 1 minus sin becomes 1 minus sin square A becomes cos square A upon sin A into 1 minus cos square A becomes sin square A upon cos A. Is it, children? So if I cancel this, 1 cos from here and 1 cos from here, it will get cancelled, and one sin from here and one sin from here, it will get cancelled. So what will remain here? In the numerator we are left with, yes, we are left with one sin and one cos. So this is our LHS. So children, what to do here now? Okay, we cannot solve further, anything we cannot do. So see, this is something very special question where you have to solve both the left hand side and right hand side. See, left hand side answer what we got is sin A into cos A. Now what you should do here, you should take RHS and you should solve that RHS and prove that RHS is also sin A into cos A. So let's take that RHS. 1 upon tan A plus cot A I have. So what I'll do here, I'll write that tan A as sin by cos. So it will be sin A by cos A plus cot can be written as cos A by sin A. Is it? Now what you will do? 1 upon cross multiply sin into sin square A, cos into cos square A, and I hope I am able to see that answer, and you might be able to also see the answer. I have just cross multiplied. What is the next step? When a fraction is there, it becomes reciprocal. So can I say it becomes cos A into sin A, and sin square A plus 1, it is 1 only. So it is cos A into sin A. If you want to write one more step, you can write this step. It becomes reciprocal and it's nothing but it is 1. So it will be cos A into sin A or sin A into cos A, one and the same thing, which is equal to LHS. So RHS is equal, this both are one and the same. Okay, so you can say that these both are equal. See, this was one very interesting question and tricky question where you have to solve both sides. So you can tick mark such questions. Okay, let's go ahead for the next question. So the next question we have, it is 1 plus tan A into tan B whole square plus tan A minus tan B whole square. We have to prove this as sec square A into sec square B. Okay, no problem. Let's try to solve this question. So children, as you see in the question, here already it is shown to you what you have to do. It is A plus B whole square. Let us assume this as A and this as B and this as A and this as B. So A plus B into, this is A plus B whole square and this is A minus B whole square. So just apply the formula. A plus B whole square become A square. So I'll take left hand side. A square plus 2 into A into B plus B square. So B is what here? B is tan A into tan B. Its square means tan square A into tan square B plus A minus B whole square. It will be A square minus 2 into tan A into tan B plus B square. Then can you see here plus tan AB minus tan AB, this 2 tan A tan B and minus 2A tan A tan B, this both will get cancelled. So what is remaining now, children? We are left with 1 plus tan square A. I'll write this first, tan square A, then I'll write plus tan square A into tan square B plus tan square B. What I did, I wrote this first and then I have written the remaining part. Why I did in this way? Because I am able to see, children, here I can take common that tan square B I can take as common, and here what I'll do, I'll take 1 as common. So if I take 1 common in the first two, I'll just show you, I'll just tick mark it. From this I'm going to take 1 common, and from the remaining part I'm going to take 1 common. Okay, so from the first two I can take common as 1, so it will be 1 outside. If 1 is outside, it will be 1 plus tan square A. From the second bracket I'll take tan square B common. So if I take tan square B common from the second bracket, I'll be going to get here tan square A is remaining there plus here it is 1. Okay, then I can see that throughout the bracket I have 1 plus tan square A, and here also I have 1 plus tan square A, and from throughout the bracket I can take that common. It will be 1 plus tan square A. See, you may say that, sir, it is tan square A plus 1 and here it is 1 plus tan square A, but it is one and the same thing. No, if I say A plus B or B plus A, that is one and the same thing. So from the whole bracket I have taken 1 plus tan square A common, and the what is remaining here? 1 is remaining, so I'll write that remaining 1 plus, and what is remaining here? Tan square B. Now 1 plus tan square A is going to become sec square A, and 1 plus tan square B is going to become sec square B. I hope it is quite clear to you, and this is the answer. Let's go ahead for the next question. So the next question we have, children, 1 by cos A plus sin A minus 1 plus 1 by cos A plus sin A plus 1. This we have to prove it as cosec A plus sec A. Children, this type of question we have solved in the previous exercise, and you are aware about this type of question. What we should do? We should do cross multiplication here. So I'll do the cross multiplication. 1 into cos A plus sin A plus 1, that will be same. So it will be cos A plus sin A plus 1 plus 1 into cos A plus sin A minus 1, it will be cos A plus sin A minus 1 upon this is A minus B, and this is A plus B. So I'll say that A plus B and A minus B, it becomes A square minus B square. Okay, then cos A plus cos A, it's going to become 2 cos A, and sin A plus sin A, it's going to become 2 sin A, and 1 minus 1, it will be 0. Then I have cos A plus sin A whole square formula, that will be A square plus 2AB plus B square. This is A plus B whole square formula which we are applying here, and minus 1. 1 square will be 1. So can I say, children, in the numerator I am able to see that this 2 I can take common. 2 is present here also and here also. So 2 common. In the bracket what will remain? Cos A plus sin A will remain in the bracket, and in the denominator what will remain? Now you see here, I'll just show you here. This cos square A plus sin square A, what it's going to become? Yes, it's going to become 1, and this 1 minus 1 I'll write here, and what is remaining in the denominator? 2 cos A into sin A. See, this cos square A plus sin square I have written 1, and this 1 minus 1 I have written then, and what is remaining? 2 cos A sin A. So 1 minus 1 is 0. So we are left with, in the numerator we are left with 2 cos A sin A, and in the denominator we are left with 2 cos A into sin A. I hope from here you are able to see the answer. This 2 will get cancelled, and we will be getting here, yes, so we will be getting here cos A plus sin A upon cos A into sin A. So what we will be doing here, children, we'll just separate the numerators and denominators. So see, I'll write here cos A one time, and here I'll separate it with cos A into sin A, plus we have sin A, and here I'll separate it with again cos A and sin A, just separating the denominators. Why we are doing like this? See, this cos will get cancelled here, and sin will get cancelled. So we are left with 1 by sin, and 1 by sin is nothing but that is cosec that we want, and 1 by cos is remaining here. So 1 by sin is cosec, and 1 by cos is sec. This we need to prove. I hope it is quite clear to you. Let's go ahead for the next question. So children, in the next question we have, if x cos A plus y sin A is m, and x sin A minus y cos A is n, then prove that x square plus y square is equal to m square plus n square. See, these are the very easy question. Here in the question itself the answer is given, and very simple it is. If this type of question comes in the exam, these are all bonus marks you can consider. See, the value of m is given to you, that is x cos A plus y sin A, and the value of n is given to you, that is x sin A minus y cos A. Okay, now children, see, in the question it is said that you do the square of m and n and add them. Already it is said in the question. So first what we'll do squaring. So if I do the square of m, so m square, it will be x cos A plus y sin A. The square of this one, it will become, how you will do the square? A plus B whole square. So A square x square cos square a plus 2 into ab, 2 into xy cos a into sin a plus b square. See, this is your a and this is your b. So just apply a plus b whole square formula. Now in the same way n square will do. N is what? X sin a minus y cos a. We have to do the squaring of this, so it will become x square sin square a minus 2 into xy sin a cos a plus y square cos square a. So we got the value of m square and n square. What to do here now, children? Suppose this is your equation 1 and this is your equation 2. In the next step it is said that add m square plus n square. So I'll add here, add equation 1 and 2. So if I add equation 1 and 2, see, as it is said in the question only, this answer m plus n square should come what? X square plus y square. It means somewhere this addition is going to come x square plus y square. So let's add it. It is x square cos square a plus 2xy cos a sin a. I'm just writing the value of m square plus y square sin square a. I have written the value of m square. Then I'll write the value of n square plus x square sin square a minus 2xy sin a cos a. Yeah, I'll just take it upside. Yeah. Plus y square cos square a. Now see, children, here it is plus 2xy cos a sin a, it is minus 2xy sin a cos a. So this both will get cancelled. What is remaining now? Yeah. So see, I'll write this x square terms together so that we can take common from that. Okay. Yes, just I'll highlight it so that it will be more clear to you. You see this and this. And here I have y terms, I'll combine that together as well. So see, I'll get here x square cos square a plus x square sin square a. I have combined the x square terms together first and then I'll write the y terms. Y square sin square a plus y square cos square a. What I can do in this step? Come on, same in name. Here x square both side x square is there. I'll take x square common. So what will remain in the bracket? It will be cos square a plus sin square a. In the second bracket, what is common? Y square is common. So take y square common. What is remaining in the bracket then? Sin square a plus cos square a. Is it? Sin square a plus cos square a, it's going to become 1. So this is x square. Plus here also sin square a plus cos square is going to become 1. So it is y square. And here what is remaining? M square plus n square. So our final answer is m square plus n square is equal to x square plus y square. I hope it is quite clear to you and it was very easy question. The value of m and n was given to us. It was said to do square and add it. Okay, I hope it was very easy. Let's go ahead for the next question. Children, here again m and n is given, but here what it is saying? Yes, here you have to do the square and subtract. So I'll write the value of m here. M I have a sec a plus b tan a. Then I have n, that is a tan a plus b sec a. What I have to do? I have to do the squaring. So I'll do squaring here only. So in front of that I'll do, because we need space there. So m square. So it will be a sec a plus b tan a. I'll be getting it as, I'll be getting this as a square, a plus b whole square formula you have to apply, a square plus 2ab 2ab 2 into a into b into sec a into tan a plus b square, that will be b square tan square a. This is the value of m square I got. Then I'll do the n square here. N square, I have the value of n as a tan a plus b sec a. So if I do the squaring of this, it will be a square. So a square, that will be a square tan square a. See, before I solve this, you should try this question by your own. Then only you will be able to solve the maths question. If you are waiting for me to solve and then you are writing it and then you are solving, it will not help you at all. So a into b, 2 into a into b plus b square. Okay, then what will happen? I have written the value of m square and n square. Okay, what we have to do, children, in the next question, we have to subtract. Let us assume this as equation 1 and this as equation 2. This is the same question as the previous one. So we need to subtract m square minus n square. So I'll write here equation 2 minus 1 we will do, and write here m square minus n square. See, here one step only you have to pay, very important that step it is. See, whenever you do subtraction, lot of time I have said you in the previous question also, the signs are going to change. So what you should do here, whenever you have these questions, no, you should write the subtraction bracket, subtraction one in a bracket, like I'll show you. See, this is the value of m square I have written first, m square I have copied it as it is, minus, then I have the value of n square. So when writing the value of n square, what I should do, I should write it in the bracket, because all the signs will get changed whenever we do subtraction. So I'll write this in the bracket first, and when I will open the bracket, all the signs inside the bracket will get changed. So if I open the bracket now, see what I'll get, a square sec square a plus 2ab sec a into tan a plus b square tan square a minus a square tan square a minus, see, this plus becomes minus, this plus is going to become minus, all the signs inside the bracket will get changed, and this plus is going to become again minus. Okay, then see what things can we get cancelled. Plus 2ab sec a tan a, here it is minus 2ab sec a tan a, this got cancelled. Now again, as we did in the previous one, we'll combine the like terms here. See, first I'll write for a square sec square a. Where is the term for a square? It's over here and here. I'll just combine it first, minus a square tan square a. Then I'll write the term for b, that is b square tan square a is remaining in the above step, this one, and here we have minus b square sec square a. Now from the first I can take a square common, because a square is present in both the bracket. So it will be a sec a square minus tan a square is remaining here, a square I have taken common outside. Then see here, as in the question I want minus b, so I'll take minus b common here. Okay, so when I take minus b common, what will happen? See, first I'll write this sec square a. Now children, I have taken minus common, so minus b square I have taken common, so here it will be minus sign and it will be tan square a. See why I have done like this. See, this was there, so here I have to took minus sign common, minus b, so this minus into minus, then it becomes plus, no. So because of that, tan square I have written it as minus. Okay, this minus b square I have taken common, and then I have written sec square a, this as it is, and then tan square a I have changed the sign. Why? Because minus into minus it becomes plus. So whenever we have the minus sign common, it is a lot of time it is said to you, the signs inside the bracket will get changed. Now sec square a minus tan square a, it becomes what? 1. And here also sec square a minus tan square a, it's become what? 1. So I hope you have understood that m square minus n square is nothing but it is a square minus b square. Here you can write the reason that sec square a minus 1, sorry, sec square a minus tan square a, it's going to become 1. Okay, I hope it is quite clear to you. Let's go ahead for the next question. Okay, very simple question these are, just you have to do squaring and subtraction, nothing more than that. So children, in the next question we have x, y, z values are given. It is said that show that x square, y square, z square is equal to r square. So what we should do here, again same thing. See, directly I'll write x value we have, y value we have, so I'll write here x square plus y square plus z square, all square I'll do together. So it will be r cos a into cos b plus y is given to me, that is r cos a into sin b plus z is given to me, just I'll erase this one. Yeah. So r cos a sin b, then I have z as r sin a. Then children, here it is all its square. This is x square we have, then we have y square, and it is said z square. So this all values I have written. I'll do the square of this all. Now when I do the square, it will be r square cos square a into cos square b plus r square cos square a into sin square b plus r square sin square a. So all square I have done. What is common throughout the bracket? I can see r square present everywhere. So I'll take r square common from every bracket. Okay, fine. So what will remain in the first? It will be cos square a into cos square b. From the first I have taken r square common, so it will be cos square a into sin square b. R square I have taken common, then plus sin square a. Then again what I can do here, see, I want only r square this side, so somewhere this all is going to become 1. Okay, that we need to check now how it will become 1. I can see here children, cos square a is present here also and here also. I'll take cos square common from the first two terms. So cos square I have taken common. What will remain here? It will be cos square b plus cos square is outside, cos square b is outside. So cos square is outside. So what will remain here? In the first term it will remain cos square b. In the second term it will remain sin square b. And here I have sin square a. So it will be sin square. Now see, so cos square b plus sin square b, it's going to become 1. So it will be cos square a into 1. And here we have sin square a. So cos square a into 1, it's going to become cos square a. And cos square a plus sin square a. Cos square a plus sin square a, it's going to become again 1. I hope it is quite clear to you. So r cos square a plus sin square, it's 1. So it will be r square. And this only we have to prove. So this is equal to your the given thing. So I can say that x square plus y square plus z square is equal to r square. I hope it is quite clear to you. Let's go ahead for the next question. See what we did in this question children, we have squared x, we have squared y, and we have squared z, and then the sum of this all, what it came? R square. I hope it is quite clear. Let's move ahead. So children, in the next question we have m value is given to us cos a by cos b, n value is given to us cos a by sin b. We have to show that m square plus n square into cos square b is equal to n square. So what I'll do here, first of all I need m square. So I'll do the square of m, that will be m square, that will be cos a, m square is cos square a upon cos square b. Okay, I have done the square of m. Then it is said we need n square as well. So I'll do the square of n. So n will be what? Cos square a into sin square b. As it is said in the question, I am doing that. It was m square plus n square. So I have done the square of m, n square. Then add. We'll add m square plus n square as it is said in the question. So if I add it, I'll be getting m square plus n square as, it will be cos square a upon cos square b plus cos square a upon sin square b. Here the denominators are not same, so what is the next step? You should cross multiply. So it will be cos square a into sin square b plus cos square A into cos square B upon cos square A into cos square B into sin square B. Okay, so I have written that by cross multiplication. Now what I should do here? Children, see, in both the terms I can see cos square can be common, so I'll take cos square common. I'll just make a line over here. Yeah. So in the numerator I can see there what is common, cos square A is common, both it is present in both the terms. So cos square A I have taken common. What is remaining in the first? Then it is remaining sin square B is remaining there. Then plus here cos square I have taken common, so what will remain here? Cos square B. And in the denominator what we have then? In the denominator we have cos square B into sin square B. So sin square plus cos square, it become what? Sin square B plus cos square B, it becomes 1. So I'll say that it will be 1 here. And in the denominator I have cos, okay, here it is, sorry, sin cos square. So here it is, children, cos square A, it will be as it is. And sin square B plus cos square B, it's going to become 1. In the denominator we have cos square B into sin square B. Okay. Now see, what we need to prove it, we got the value of this as m square plus n square, and we want m square plus n square into cos square B. So what I'll do here now, I'll write here m square plus n square, we got the value. I'll multiply this m square plus n square into cos square B. Okay, I'll just take it upside. Yeah, fine. So I'll be getting here m square plus n square is equal to, so what I have done, I will be multiplying m square plus n square value with cos square B. M square plus n square, what we got this value, so I'll write it over here, cos square A upon cos square B into sin square B. This is the value of m square plus n square, and this I'll multiply it with cos square B. So children, you can see that the same in the numerator, same in the denominator will get cancelled, and what I got it as cos square A into sin square B. Now you say me, is it the value of n square? Yes, you see here, yes, it is the value of n square. Okay, therefore whatever is asked, we have proved that is m square plus n square is equal to cos square B is equal to n square. I hope you understood the concept. We'll go ahead for the next exercise. I think this was the last question from this exercise. I hope you have understood each and every concept in detail. Still, if you have any doubt, any query, you can text to me personally on my personal WhatsApp number. Thank you. Have a nice day.